I'm Stan Pennington, program manager in the Windows Client Media Pipeline team. I've been at Microsoft since 2000. I've been the PM owner of DirectShow for nearly all that time. So some who do media coding may have run into me in the past. Thank you all for coming. I think we need a bigger room. So for today, we're going to be digging in, definitely a deep dive, into Media Foundation. Specifically, there are two technologies that we have in Windows 7 that are very interesting for easy integration into existing or new designs. One of those is, the groundwork is laid by the addition in Windows 7 of asynchronous Media Foundation transforms. That allows us to have hardware codecs, and that then enables fast transcoding, where we have an API for. Secondly, we have support in Media Foundation as of Windows 7 for high definition USB video class 1.1 webcams. Now, I'm not going to assume too much about people's knowledge of Media Foundation. We're going to go through a little bit of history. It seems like every time I talk about media infrastructures, I get into a history lesson. And so context, as a PM, context is very important to me. I think you'll find it useful too here to navigate through all the pieces of this technology. So when I say here media infrastructures, actually Windows is considered the platform. So we provide technology infrastructures within Windows. And our team, for all you've heard in the last few days about managed code, our focus is primarily on unmanaged APIs. And there are actually some really good reasons for that. First of all, there are, for audio and video manipulation, whether playback, transcoding, streaming, there's a need to be fairly real time. In fact, down to sometimes 16 or 30 millisecond deadlines. And so one of the problems you can run into is you can try to solve that with buffering, more and more buffering, gets your footprint bigger. It also makes it so it can be difficult to have good transport control response, good response to flushing and other activities. So you don't want to just use a huge amount of buffering to cover for this. You also get a long delay from, say, a live broadcast case. So in terms of performance, what we see typically is that if you're doing something very intensive like a codec, that as a rule of thumb, you get about a 2-to-1 performance hit in managed versus unmanaged. We have actually seen this specifically with certain implementations we've done. Now, beyond that, because we're talking about nearly real-time operation, that the garbage collector in managed can cause things to be delayed significantly. Now, of course, ways you can deal with that, you can try to actually manage the lifetime of your managed objects yourself, but at some point that gets back to being almost like doing unmanaged code again. Now, of course, although the heavy lifting is done in an unmanaged pipeline or unmanaged components being strung together, you could expose the config, control and status, all of that, not the actual streaming, through into managed APIs. And there are even, for example, we have an MVP who's done that. But for us, the problem is that it can create a number of legacy issues and roadmap alignment problems going forward. So we leave that mainly as a value add for customers and other integrators. Now, we have 4 infrastructures. This spans about 17 years. And the first is Video for Windows, 1992, DShow about 95. Windows Media Format SDK is a parallel track around close to 2000, and then Media Foundation. Now, another thing to understand about the way our technologies work is that there are really 2 models. One is consumers of the APIs making solutions, whether utilities or full applications, and then also data flow components. We have extensibility points. Actually, DirectShow has a lot of extensibility. You can replace almost any filter. And then the other solutions have selected amounts of extensibility, a little more targeted. And usually that's driven by media format requirements to add new components. Now, of course, a single vendor could be do one, do the other, do both. In fact, it's possible to have a one-to-many relationship of someone providing codecs to several other vendors. Now, just to put this in perspective, that what we're saying is that Media Foundation is a long-term effort. And you can see in comparison to our other technologies, Video for Windows starting in the early 90s, we actually still, to point out, we make use of a few pieces of technology from there, primarily the Audio Codec Manager Codecs. And for D-Show, it started out in 95, that DVD didn't really come to fruition until about almost 98. And TV support hit its stride with BDA in about 2001. Of course, D-Show is still supported, still used heavily. Format SDK is a parallel effort. Also, interestingly, Video for Windows is, of course, a single container, AVI, solution that moved into, influenced a D-Show multi-container solution. Format SDK, a single container solution that then influenced, along with D-Show, the two of them took the best features, best ideas from D-Show and Format SDK into MF. Now, to look a little bit more on the right-hand side, of course, critical to this is format support. And we have, of course, filters in D-Show. We still use ACMs. We use VCM codecs for Format SDK, DMOs, and ACM codecs. And finally, when you get to MF, we have everything being consolidated to MFT codecs. Sometimes under the covers, we make use of ACM codecs wrapped via compile time. But we are standardizing on this codec model. And really, for future-proofing, the MFT model is where we're going. As you can see, in terms of the shading, I've made it so that MF looks like it's the area where we are putting almost all of our investments going forward in terms of new technology, and especially new format supports. In Windows 7, you probably heard about the fact that we have H.264 and AAC, including HE, V1, and V2 within the MPEG-4 container. We have other selected format solutions. Those have been covered in other talks, even last year's WinHEC. You can refer to those. Now, if we look at how, it's very informative to see how we use the technology. It's not like we have a whole bunch of hidden things. I'll point out a few places where we have a few non-public items. But it can be really useful to see how are we using these core audio-video technologies. And that'll give you some indication as far as recommendations for what you need. For Media Foundation, mainly, we have non-streaming ASF. And to bounce down, Format SDK is still our solution. It has so many years of doing true streaming, traditional like RTSP, MMS, other streaming. And so, but for MF, we also handle, of course, MP3, MPEG-4, specific AVI permutations. Now, when you talk about containers and codecs, you actually have kind of a modular system with most, where the container is really just either a file or a stream holding individual codecs. And so you can have all sorts of permutations of those. So we have great support for AVI. In Media Foundation, we added specific support for digital still cameras that were very popular for Windows 7. Now, of course, we also have metadata handling that we have migrated over from Format SDK to Media Foundation. And then our transcoding all consolidates to using overall the Media Foundation pipeline above the level of our infrastructure at about an app layer, say for Windows Media Player and such. Media sharing that you see in Windows 7, Play 2 and other things integrate further with this technology and provide very targeted solutions. Now, D-Show, of course, grew up with DVD and TV, and even just MPEG-2 technologies in general. A lot of custom solutions for video editing, other I/O. And so D-Show remains quite mainstream for those technologies. So Format SDK also, one of the main values of it in the past has been that you can integrate with just an existing application very easily with its ASF reader and ASF writer object model without having to retool very much. Now, still looking at how we use these things, one of the messages to get across is that historically, Windows Media Player, many people want their formats or their value adds to be able to work in Media Player. and also within our OCX. Of course, in the evolution of the player, from 6.4, the old Windows Media Player 6.4 was a very thin UI layer over DirectShow. So extensibility could be assumed from DShow itself. But in reality, how we use the technology in Windows 7 is we make use of any of the three main infrastructures that I've talked about, a tiny bit of VFW, as required, just to get the best end user experience. So, and then I mentioned that MF is making use of, WIMP is making use of MF for transcoding. Yes, in Windows 7 we have additions for a hybrid with DirectShow in order that a number of very old codecs could still be used as far as the sourcing content into the transcoding pipeline. Now, Media Center leverages the WIMP OCX. They put in a custom presenter and then tie it into their Splash renderer, and that works for everything but TV and DVD. TV and DVD are very custom in Media Center. Beyond that, we also, other than in WIMP synchronization for devices, we have shell drag and drop transcoding, and that, of course, in Win 7, where you can, and that was shown in the keynote this morning, as you may have seen, just drag over your file to the icon for the device, and it will pop up saying, do you want to transcode this? And off it goes. So, one other thing to note about Windows 7 is that as of Vista, we had the protected media path, and what you would see is an extra process there. Of course, the whole idea of the protected media path was to run DRM content in a walled-off separate process in what's called a protected environment. And that we actually ran it nearly all the time for content that Media Foundation supported in Vista. And the reason for that, specifically, was because we wanted a feature of being able to do seamless crossfade in audio between DRM and non-DRM content. Now, being able to mix between those cross-process is very difficult, so we just defaulted that. So often you would see MFPMP running, you'd see it using a bunch of resources for video. This was the reason. For Windows 7, we determined it was more important to be more performant. So now what you'll see is that MFPump only runs when you specifically are playing DRM protected content that is supported in Media Foundation. Yeah, go ahead for a second. I'm sorry, let me get a little closer. Go ahead. We'll have to go very quickly. I'm tight on time.
Okay, I'm trying to understand exactly where the line goes between using Media Foundation and Format SDK, because, for example, we have ASFs using script streams, and we know it takes Format SDK, and when you take it out, and that part is not really documented.
Yes, and so let me go into that a little further. Thank you. So it is actually, for Media Player, very complex in the decision tree between the use of Format SDK or Media Foundation. And one of the factors you run into there is that in Vista, Media Foundation didn't have support for, even for non-streaming cases, didn't have support for binary streams, for script streams and other things. In Windows 7, we did add that support into MF. So for non-streaming cases with strip streams, it will use MF. Now, the problem here is that if we document this, and so let me go on to my segue into my next slide. One of the main takeaways from this is that Windows Media Player and, of course, Media Center using that technology, and also the OCX, this is all put together to try to maximize the experience, whether it be performance, overall quality, and everything. This is why we did not document that level of integration. So what we're asking is that if you have specific questions, if you need clarifications, come to us, contact me. I can help with giving you some idea there. We will not document this formally because it limits our ability to actually improve the player. So the actual extensibility points are shown here that are documented. Okay, so why do we use Media Foundation? Actually, DirectShow, if you're used to it, you'll have filters for file sources, filters for demuxes and muxes, filters for codecs. And what we run into is that in a newer OS paradigm, we want to make use of the iStream object in general for input and output. So effectively what you see, or what you don't see, when you directly in your graph for Media Foundation is an actual source and sink in the way you're used to it in DShow. What you see is actually a media source that truly maps to a DShow demux, a media sink that maps to sort of a combination, depending on if it's file or rendering, a mux or a regular traditional renderer. So another key point is that we, in some ways, grew out of DirectShow internally because we ran into problems with putting together filters that may have push and pull configurations. One of the biggest difficulties was being able to support on-the-fly changes to graphs. We did have a thing called dynamic graph building. It was very limited. So really the idea of taking all the connectivity, there's no pins in Media Foundation. So you move that up to a higher layer. It's much easier to orchestrate the streaming activity. You have the potential that on a dime you can say, oh, I just hit sample X. Now I'm going to reconfigure, boom, sample X plus 1. And that is very difficult with DShow because of the time it takes, especially with all the code in the base classes, to go through and negotiate for format changes, handle all the pin conditions and everything. We also, in re-architecting, were able to have better control of threads. Now in DShow, you have a lot of autonomous threads running within filters. It's really hard, except by convention, to try to get people to have some kind of control over these filters. One thing we were able to do as part of that, as in Vista and on, is to have the multimedia class scheduler service that allows us to actually put these threads into dynamic control to where they can use 80% of CPU for very important AV scenarios. And then so it'll just control the thread priority to make that happen. That is very difficult to retrofit into DShow. Now, one other point that we talk about is DShow, a filter can be almost anything. By convention, we have sources, we have codecs, we have, there's monolithic cases where you may have something that's a source and a demux and a decoders. One of the things we really needed in Media Foundation was to constrain these roles quite a bit more, where we say a source is a source, a transform is a transform, a sync is a sync, no crossover. The topologies become, so what we used to call graphs, we now call topologies, are much simpler. They have each node being typically a source, a transform, a sync, maybe a few more transforms in there, but still not that spaghetti configuration that you sometimes get in very complex DShow graphs. And that also then allows us to innovate, where we can come in with what I'll be talking about here in a minute, have an industry initiative to have hardware-accelerated codecs that can plug in as MFTs. And these things are all constrained that they are just decoders and encoders. They're not video processors. They're not doing other roles. And so it makes it so the interoperability in the ecosystem is more guaranteed. Now, for features, just a refresher here, Vista, everything gravitated to what we call the media session. That's a model where you go through several steps. Some might not call it really a high level API, where you have the concepts of a presentation descriptor, stream descriptors. You go through a resolve a topology. It takes some work, but at least it is consistent. You can use it for playback. You can use it for transcoding. And then, of course, formats. It was really just a next generation from the format SDK, which is ASF and MP3. Now, for Windows 7, we kept the backward compatibility, very important. But we also added some new APIs, and these highlighted ones I'm going to be getting into a little bit more. We have the source reader, symmetrically the sync writer. These are much like the ASF reader and writer of old of format SDK. Very lightweight objects that you can get at the bits, you can put the bits. We have the transcode API. That API provides nice simple standardization of transcode functionality that IHVs can plug into. Now, additionally, of course, we have the format support. It's been mentioned in several other venues. And another thing I'm going to talk about here is specifically async MFTs, how they make hardware codecs work. And then finally, our capture support with an internal object we call a device proxy is kind of useful to take a look at. So really quickly, for those who may not have seen it, we actually have, for those who may have seen GraphEdit, of course, this is around for many years. We have a equivalent in Media Foundation that if you go to install the Windows 7 SDK and you look down in here under TopoEdit, since we're calling it topologies, TopoEdit, and it's associated, just like GraphEdit has proppage.dll, TopoEdit has tedutil. And so if we go ahead and fire that up, what you'll see is actually in the original incarnation in Vista, you get the idea of going through the whole presentation descriptor. So here's this wildlife video, and then you would add an audio renderer, you would add a video renderer. You actually, this is just like what you do programmatically. Of course, this is a visual simulator. Whoops. Oops, sorry, I'm gonna get my connect it all up. And then if we run it, actually, excuse me, oops, I gotta move this out a bit. Oh, I had to resolve the topology first, excuse me. Actually got a connection here to fix. One more time, sorry. Resolve the topology. This is just like what you do programmatically. Yeah, we got a little glitch in there. Oh, well. So anyway, you can play a piece of content. Now, what we've done to make it simpler in Windows 7 is that we can just render a file, just like GraphEdit's render file, and go in. Instead, it will build the topology for us. So there's a start on TopoEdit. It also has several other features, including the ability to specifically add transforms, to go in and add various types of sources, your own MFTs, so you could do something like just put in a GUID. You can actually even set up a transcode pipeline. Okay, so to go on. Now so what enables us for transcoding, fast transcoding, is the asynchronous MFT. Now, really, the MFT is just a next generation DMO. We took it and modified it so that it talks MF, media types and samples. And also, so the simplest model to be able to run an MFT, it has no pins, is that you just synchronously call process input, process output, process input, process output, and then finally at some point, especially if you're like a decoder, you'll get an output saying it's ready, and then you can consume, say, a decoded frame. So very simple model, very useful. Of course, one of the problems we have is if it's backed by hardware. Now, let's say you have an audio branch and a video branch, and they are running at different sample rates. That you're going to be very inefficient if you're going through and saying, okay, I'm polling. So basically, we needed a way to have it be event-driven. So our changes to create the async MFT. For compatibility, we have to lock it. It shows up as sync first. And then there's certain interfaces that you make use of, and then go through and unlock it, and then it has events for the type of things you'd expect. That it needs to be fed, has an output ready, it's drained, those kind of things. Now, when you use this specifically for hardware acceleration, the model is more generic for an async MFT. It could be for other things. But we could have applied it to both video and audio codecs and processors and such. Now you ask, why, if we have DXVA already, why did we need a new model? Well, the reality is DXVA had no support for any encoding. That's something that could have been added, but really when you see we go further, there's a fairly good reason for this, in that we wanted to enable other classes of accelerators. So also, if you made a hybrid where you had DXVA for decode and then had some other solution, like a discrete chip for encode, it can be very inefficient to be doing copies over from vidmem to sysmem. So usually you want to stay within the technology. If you're going to do a GPU-based decode, you want to do a GPU encode, and similarly for a discrete piece of silicon. So now when we go in and actually put this in for acceleration, really, any ISV can make a hardware MFT, and they or any other ISV can consume it. Of course, with any, especially codecs, we're going to be talking about here a lot, you always have to be cognizant of any usage fees, any other licensing rules. And really, if you don't need a codec, like I talked about at the very beginning about the different models, if you don't need a codec to be available to other vendors or to other solutions, please keep it local. This is kind of like DShow, some of you may have heard of, we call codec hell. That everyone registers a codec, they jack the merit of it. Pretty soon, your codec gets into other people's apps, and so people start having to do defensive programming and go through and have hard code their own solutions. So this is something in Windows 7 with this MFT register local that you can use to just have your MFT be your own. Now, when you go to actually use this at a programming level, what happens is it's fairly automatic if you want it to be. You don't have to ever code to the async MFT itself. There are some overall reg keys that typically the OEMs set on once they're comfortable with the solution on a given box being ready. But of course, there are certain upgrade scenarios where a graphics vendor or other driver vendor may want for their value to set these keys. But they're just under the Media Foundation path, H key, HKLM, and on. It's all documented. Now, so one thing though is if you're making your own app based upon MF, say for the session, and you want to pull in these things, you have to actually set an optional attribute, MF topology hardware mode. And then that will enable, so as an opt-in, to pick it up. Now, another point though is that MF and Vista, in not wanting to recreate the merit problem that we have with these show filters, in Vista, it was left that there is no determinism as far as overlapping component selection. Basically, due to the vagaries of how a component gets looked up in the registry, and you could get one, you could get another. And actually, for very robust app development, you would want to pick your own in that case if it is very important to you. But going to Win 7, we needed a way to be able to deal with this overlap because moving beyond, of course, ASF and MP3, we were going to have a lot more possibility of overlap. So what we had to do is say, if we just had merit again, people would say, regardless if they're a software codec, I am a hardware codec, and they would get pulled in preferentially. So what we did is we came up with a system that makes use of what we call trusted merit, and that I will go into in a little bit of detail. I have slides here that are really for posterity, for you to have it for reference. I'm not going to go into great amount of detail with the time we have. But if you're controlling things from your own topology, so like other than Media Player or somebody else's app, you can specifically use MFT enumix or silver flags to control whether you want to enumerate hardware codecs or not, whether you want to pick up other types of transforms, several classes of components. Also on async MFT, so as I mentioned, really kind of talked about this, not only for our own experiences of WIMP and Media Center and such where they're using MF, but also if you are using the automatic topology resolution capability like I showed on TopoEdit, we have to constrain the preference. Codecs are responsible for a number of security, reliability, and performance issues. In fact, across Windows, third-party codecs account for almost 10% of our crash telemetry. So this is very important to us, especially in the security realm, to make sure that we're not picking up codecs by default that we can't trust. This all goes down to a licensing program. I'm going to go through this very quickly, stealing a little bit from Matt Pietrek. So the way we structured this in terms of constraints for Windows 7, only for video codecs and processors. These things get preferred if you go through the license program. And really only, we'd have a one-to-many relationship if we allowed anyone who could consume a hardware codec to actually wrap it into an MFT. So it's limited to the actual IHVs that make the core codecs. Now, there are two models, GPU-based, as I mentioned, and almost any driver model can be underneath an MFT. It's basically the abstraction. You can also have AV stream. That's what we have within kernel streaming as part of DirectShow. We've had that for years, making use of AV Stream. And so we have this same kind of proxy model like DShow has, where we bring it up from kernel mode into user mode through a proxy provided by Microsoft. If someone doesn't want that, they can make their own. There is a test suite associated with that. It shares some assets with our media performance test kit that's used heavily by OEMs. So a lot of test vectors for WMV, for MPEG-4, other formats. Now, also in the license program, you can have transcoding only codecs. You could branch out into general codecs. Now, when you move from transcoding into playback, of course, the risk to security, reliability is all increased. So those codecs need to be better. So this, of course, this test program is there to police that. Now, in order to have such a codec work, it has to have the attributes that tell the pipeline that it is the proper hardware codec. This is all documented. That's directly done for regular MFTs, vendor MFTs, and then if you're doing kernel streaming for AV Stream, it's through KS property sets. So the neat part is, if you're at all used to kernel streaming in DirectShow, where things could actually communicate in hardware to be efficient rather than bouncing up off a system memory, we also have that in AV Stream, MFTs can actually negotiate for what's called hardware mediums, just like in KS, and in fact, it's using KS under the covers, and be able to do hardware data flow that's then virtually represented within the topology. Now, going a little further, in our Windows Media experiences, we leverage that transcode API that we have. And I have to note, though, that syncs are special. Syncs do not have normal enumeration and extensibility. So adding like a new format for Windows media for transcoding is not possible today. But for third-party applications, you can add your own syncs. And also, there are several events that we document for the async MFT that we don't necessarily use. And so here's an opportunity for third parties to be more efficient in hardware state machines. Also, really quickly, just putting this up as an eye chart, various formats, because of the complexity of how our infrastructure selects the different assets within our technologies for format. We have cases where it doesn't make sense to have an MFT codec be trusted merit because there's no inbox equivalent. So this is just mainly for reference. Now, when we go to actual fast transcoding, inbox in Windows 7, as you saw in the keynote, it's geared toward portable devices. And it's all based on this media session we talked about and done in WIMP and Shell. Here's an area where we use a private implementation. We have our own wrapper for a wrapper media source in Media Foundation that wraps a DShow graphlet. And the reason for that is that, of course, we want the broad format support from older codecs that may never be transferred into MFTs. The reason why it's private is because, like I said, DShow filters can be highly unconstrained. So if we provided a wrapper to everyone, there's always going to be a certain subset of codecs with private interfaces or other things, and they're going to have issues. So rather than make that implementation public, we have kept it internal for the benefit of this. It leaves open to others to be able to do their own wrappers. The technology is definitely available. Here is a diagram of what session-based transcoding would look like with hardware acceleration, showing actually a GPU case. Again, Media Foundation, you've got the idea of byte streams when you go to file or network. And then, of course, the elements of the topology are being resolved. Now, so we also have, as part of our effort around Media Foundation, if you go to the additional resources, you'll see that on the last page, we have a new blog. And that blog is going to be showing some information about our efforts to have new samples, efforts around new tools going forward. We have several samples that are already built up. I'm going to show you one that's pending. You can't get it right at the moment, but you will be able to soon. And so the idea here is what we have is this is actually a tool, or a sample for typically like file-to-file transcode, so that someone could integrate this technology. It's actually shown as a managed sample, so it's interop wrapping our core unmanaged technologies. And the fact that I actually have it built up, again, we're running very tight on time, so I'm just going to show you it's a very simple little dialog that goes in, so we could take and say, take this file that everybody's seen, go in and convert it, maybe simply enough. Let's say we're going to down-res it for a different device and constrain the quality, and then we go ahead. Now, I'm not going to wait around for this because we are in a hurry with a 45-minute session, but I'll just show you as an example. Then that makes it into the smaller video. That is making use of hardware acceleration. OK. So now we're going to move on from transcoding into capture. This is the second area of very easy integration of these technologies. And we have, I'm mentioning this internal object, we call it DEB proxy, device proxy. We make heavy use, of course, of kernel streaming, as I've mentioned. There's been this very nice synergy over the years between kernel streaming and DShow, in kernel versus user mode. And we have leveraged those assets where needed to, but we wanted to make it lighter weight. The one problem about kernel streaming is, of course, since you end up with a graph in kernel mode, it becomes very heavyweight. And there is, we really like to make this highly performant, very easy, again, to be dynamic, especially for things like where maybe you're doing collaboration and you want to have maybe a camera come up, one disappear, audio sources come and go. This supports mainly USB video class webcams. Here's an example of an HD webcam from Microsoft. We can also support audio capture. There isn't full tuner support. So that really squarely remains in the DShow realm for Windows 7. And of course, Media Center is solidly using that technology. Of course, for the future, we will continue to evaluate whether it makes sense to have some simpler model for some level of tuner support in Media Foundation. Of course, tuners are not what they were. Analog tuners are kind of going by the wayside slowly. Now, moving into a little more detail about this is that, again, it's sort of automagic, if you want it to be, that Media Foundation picks this up, and you don't have to actually code directly to a media source. What you can do is basically just create it. You pass it into our source reader object, which I'm talking about in a second, and using this API. And then if you want to enable hardware codecs, they can be used even here. Same kind of thing. You have an optional attribute you set. And then, so for going forward, I'm going to talk mainly about the HD webcam capture case. There is a plug-in model for it so that ICVs for cameras can do a value add in Win 7. So that, of course, that class driver model sometimes can be limiting. In this case, we have the extensibility. And the diagram there is very useful in that regard rather than reproducing it here. The source reader is a really great object we've added, again, akin to the old ASF reader, but for multiple formats. It allows us to output compressed or uncompressed, supports devices. It's simpler. We don't want to allow just any kind of topology in it with all the resultant complexities. We make it very simple. It can support an actual media source inside and a transform, and then have some specific conversion capabilities, say for color space conversion. Now, it has both async and sync APIs. It's kind of interesting that, and that was true of even the old ASF reader, that async, of course, is very good. You're doing Windows-type programming, typical Petzold thing with events. Now, down at the low level of almost like scripting, the sync APIs become very useful. And then even up at the very highest level, the sync APIs could be useful if you're doing multi-threading and you want to basically have something appear as a more procedural task. The reality, though, in this scheme of this thing, the async is the best model to use because there's blocking that occurs in the sync model for things like source resolution. So we recommend overall you use async even though sync's there. Unless you're doing something very simple, you want very quick integration. This is really great for if you want to be able to just get at the bits, you want to be able to throw them into some rich composition, or just like integrate with any pipeline you have, and just generally adding to an arbitrary design. And here's a obligatory picture of it, of how it plugs in just like I explained, and also has the capability for hardware acceleration. So we do have a sample of this. This is actually a sample that's already in Windows 7 SDK. Thanks, Mike. So going back up a little bit. It's called MF Capture D3D. I've already built it here. The idea is it instantiates that source reader, as I mentioned. We're just going to fire it up. And you can see that with the webcam, it's actually working. Again, could do a lot more with it. I could actually show this working in TopoEdit. You can actually just fire this up and do the same. Now, for Media Foundation development, one of the other things is since the model is significantly different, MF is generally async. There are some challenges there when you're programming. There also are worker queues for media sources, going to a newer concept of rather than having a bunch of embedded threads, that we can batch this work, we can control, actually the scheduling of the work, the actual work operations. We do have some ETW events, but they're very limited for performance reasons. Again, a very near real-time operation. We also have a set of WPP events internally that were there for Vista, and we made use of those for debugging purposes primarily, a lot of function entry, exit, and such. That also caused some performance overhead even on released binaries. We have, in optimization, we removed some of these things for Windows 7, so we said, well, we need a way to get this back. So again, this is marked as future. I have a demo here, so I don't have time to show it, but of this MF Trace tool. It actually goes in, planned for release next year. We are actually betaing it with some specific partners right now. It uses Microsoft detours to hook public interfaces so you don't get the overhead in the basic runtime for Windows, but you can add this in and then we can make it extensible, it has XML for it to be able to define additional events. And we can consolidate all the other event types, including ETW and such. You can have it spew to a regular console output while you're doing things. Just simple command line. You can redirect it to a file, use something like textanalysis.net. And then we also have added some commands to be able to do things like show you topologies, show you graphs of timestamps and things. Very useful. Getting down to near the end here, we also have, as I mentioned, TopoEdit. That was interesting on my graphics hardware, that little extra line. But TopoEdit, it fully supports hardware-accelerated MFTs now in Windows 7. So overall, we're saying is you have this new technology, should be a very low barrier to entry to be able to add it to existing or new apps. Of course, enables that fast transcoding you saw in the keynote, allows you to have webcam capture. There are so many laptops and devices out there that are UVC 1.1 compliant now, especially built into laptops. And also that we are working on improving the tools. So we ask that you evaluate MF and just consider integrating it into areas where you might want to be adding this kind of functionality. I have specific links, because there's so much content on MSDN to these topics, and also mentioning the blog and our forum. And then, finally, we really like you to fill out the evaluation. There's actually a donation program going on around that. If you fill out, you actually end up donating $1 if you fill out the online form. And if you do 5 or more, apparently it's a little more money. That's great. And also to mention Channel 9 as an incredible resource to be able to get more information, including additional videos that we have planned around like format support and such. And that's it. So thank you very much. And we have just a few minutes for some questions. I have to state that I am somewhat hard of hearing, so I may have to actually run over to you to make sure that I get the gist of your question. Yes. Here, I'll come up here. Yeah.
Right now,
Hi.
the settings for H.264 encoder is so limited. So, for example, we cannot say turn on Quebec or turn off Quebec and the
Yes.
plugin filter or whatever. And when we do transcoding for specific device, we still need to use our encoder to be sure that the format will be matching. Do you plan to do something?
So let me restate the question. That The H.264, we have encoding capability for H.264 and AAC in Windows 7. That support was specifically put in place for what you saw in like the keynote for portable devices. And that class of devices typically is running with the lower profiles at lower resolutions, and also for audio limited to LC. So even we're limiting the bit rate and such. That is definitely a first generation of those technologies. It is our desire to improve those because, of course, providing codecs in the box makes it easier for third party. Of course, as it exists today, the codecs do not have more functionality, as you've noted, for doing things like being able to control callback. The actual core codec does callback, but we do have an intent to do that. Our actual ability to implement that, say, in the next version of Windows will be subject to a lot of planning that has yet to be done. So if you'd like to talk more about that offline, I will be at the track lounge from 3 to 4 o'clock and be quite willing to speak with anyone. I think we're basically out of time. I might be able to field, well, I probably shouldn't even field one more question because the next speaker is ready. I did try to pack in as much content as I could for you in these 45 minutes to give you the most benefit of basically a reference in this slide deck that you can come back to later. Okay, so please come to the track lounge at 3 o'clock if you have any questions at all. Thank you.